Welcome, stargazers, to a tranquil voyage through the cosmos. Tonight, we embark on an awe-inspiring journey to explore the realm of exoplanets, those distant worlds orbiting stars beyond our own sun. As you settle in for a peaceful slumber, let's unravel the mysteries of how we detect these celestial bodies and ponder the tantalizing question of whether they could harbor life. Prepare to drift into a serene state of mind as we delve into the fascinating science of exoplanets. Our quest begins with the fundamental question: what exactly is an exoplanet? Simply put, an exoplanet is any planet that orbits a star other than our sun. For centuries, the existence of such planets was purely speculative, a realm confined to science fiction. It wasn't until the late 20th century that technological advancements allowed us to peer far enough into the cosmos to confirm their existence. The discovery of exoplanets has revolutionized our understanding of the universe, revealing that planets are far more common than previously imagined. Now, let's explore the ingenious methods scientists employ to detect these far-off worlds. Given the vast distances involved, directly observing exoplanets is an incredibly challenging feat. Planets are much smaller and fainter than their host stars, making them difficult to spot amidst the glare of stellar light. As a result, astronomers rely on indirect methods to infer the presence of exoplanets. These methods are like detective work on a cosmic scale, piecing together subtle clues to reveal hidden worlds. One of the most successful techniques is the transit method. Imagine a tiny ant crawling across a distant spotlight. As the ant passes in front of the light, it causes a slight dimming of the light's intensity. Similarly, when an exoplanet passes in front of its host star, it blocks a tiny fraction of the star's light. By carefully measuring the star's brightness over time, astronomers can detect these periodic dips in light, indicating the presence of a transiting exoplanet. The transit method not only reveals the existence of a planet, but also provides valuable information about its size. The amount of light blocked during the transit is directly related to the planet's diameter. The Kepler Space Telescope, launched in 2009, was specifically designed to use the transit method to hunt for exoplanets. Over its 9-year mission, Kepler identified thousands of exoplanet candidates, revolutionizing our understanding of planetary systems. One notable discovery made by Kepler is Kepler 186f, an Earth-sized planet orbiting a red dwarf star in the habitable zone. This discovery sparked great interest because it was the first Earth-sized planet found in the habitable zone of another star, although it is still unclear whether this planet is habitable. Imagine watching the sunset on Kepler 186f, with a red dwarf star casting a warm, reddish glow across the landscape. The transit method is a powerful tool for exoplanet detection, but it has limitations. It only works for planets whose orbits are aligned in such a way that they pass directly between their host star and our line of sight. This means that we only detect a small fraction of the total number of exoplanets that exist. Another powerful technique is the radial velocity method, also known as the Doppler wobble method. This method relies on the fact that a star and its orbiting planet both revolve around their common center of mass. While the planet's orbit is much larger, the star also experiences a slight wobble as it responds to the planet's gravitational pull. This wobble causes the star to move slightly towards and away from us, resulting in a periodic shift in the star's light spectrum. By carefully measuring these shifts, astronomers can infer the presence of an orbiting planet and estimate its mass. The radial velocity method is particularly sensitive to massive planets orbiting close to their host stars. These so-called hot Jupiters exert a strong gravitational pull on their stars, producing a readily detectable wobble. The first exoplanet ever discovered, 51 Pegasi b, was found using the radial velocity method in 1995. This discovery sent shockwaves through the astronomical community, as it challenged our understanding of how planetary systems form. 51 Pegasi b is a gas giant similar in size to Jupiter, but it orbits its star incredibly closely, completing one orbit in just 4 days. Imagine a Jupiter-sized planet scorching around its star at tremendous speed, a stark contrast to the leisurely pace of our own solar system. The radial velocity method and the transit method complement each other, providing different pieces of the puzzle in our quest to understand exoplanets. While the transit method is best suited for finding planets that are aligned edge-on to our line of sight, the radial velocity method is more sensitive to planets that are oriented face-on. By combining these two methods, astronomers can gain a more complete picture of exoplanetary systems. Gravitational microlensing is another fascinating technique used to detect exoplanets. This method relies on the bending of light caused by the gravity of a massive object, such as a star. When a star passes in front of a more distant star, its gravity acts like a lens, magnifying the light from the background star. If the foreground star has a planet orbiting it, the planet's gravity can cause additional distortions in the light curve, revealing its presence. Gravitational microlensing is a rare event, as it requires a precise alignment between the foreground and background stars. However, when it does occur, it can provide valuable information about the mass and distance of the exoplanet. One notable discovery made using gravitational microlensing is OGLE 2005 BLG 390lb, a cold, rocky planet located about 20,000 light-years away. This planet is estimated to be about 5 times the mass of Earth and orbits its star at a distance similar to that of Mars in our solar system. Imagine a frozen world far, far away, its existence revealed by the subtle bending of light across vast cosmic distances. Gravitational microlensing is particularly useful for finding planets that are far away and faint, which are difficult to detect using other methods. Direct imaging is the most straightforward, yet also the most challenging method of exoplanet detection. This method involves directly taking a picture of an exoplanet. However, as we discussed earlier, planets are much fainter than their host stars, making them difficult to spot amidst the glare of stellar light. To overcome this challenge, astronomers use specialized telescopes equipped with adaptive optics and coronagraphs. Adaptive optics correct for the blurring effects of the Earth's atmosphere, allowing for sharper images. Coronagraphs block out the light from the host star, revealing the faint light from the orbiting planet. Direct imaging is best suited for finding large, young planets that are far away from their host stars. Young planets are still warm from their formation and emit more infrared light, making them easier to detect. Several exoplanets have been directly imaged, including Fomalhaut b and HR 8799b, C, D, and HR 8799 is a particularly interesting system, as it contains 4 giant planets orbiting a star that is only slightly more massive than our Sun. Imagine directly witnessing a family of planets orbiting a distant star, a testament to our technological prowess and our insatiable curiosity about the cosmos. Direct imaging is a powerful tool for studying the atmospheres of exoplanets. By analyzing the light emitted or reflected by a planet, astronomers can determine its chemical composition and search for signs of water, methane, or other molecules that could indicate the presence of life. With these ingenious methods, we have discovered thousands of exoplanets, each one a unique and fascinating world. But the ultimate goal of exoplanet research is not just to find planets, but to find habitable planets, planets that could potentially support life. What makes a planet habitable? The traditional view focuses on the concept of the habitable zone, also known as the Goldilocks zone. This is the region around a star where the temperature is just right for liquid water to exist on a planet's surface. Liquid water is considered essential for life as we know it, as it serves as a solvent for biochemical reactions. Planets within the habitable zone are neither too hot, where water would evaporate, nor too cold, where water would freeze. However, the habitable zone is not a strict boundary, but rather a fuzzy region that depends on several factors, including the size and temperature of the star, the planet's atmosphere, and the presence of greenhouse gases. Earth, of course, is the prime example of a planet within the habitable zone, with its abundant liquid water and thriving biosphere. Mars, our neighbor, is also located within the Sun's habitable zone, although it is much colder and drier than Earth. Scientists believe that Mars may have once had liquid water on its surface, and there is still the possibility that microbial life could exist beneath the surface. But the concept of habitability is much more complex than just the presence of liquid water. Other factors that can influence a planet's habitability include its size, mass, composition, atmosphere, and magnetic field. A planet's size and mass determine its gravity, which affects its ability to retain an atmosphere. A planet's composition affects its geology and its ability to generate a magnetic field. A planet's atmosphere regulates its temperature and protects it from harmful radiation. A planet's magnetic field shields it from the solar wind, a stream of charged particles emitted by the star. Earth's magnetic field, for example, is crucial for protecting our atmosphere from being stripped away by the solar wind. Without a magnetic field, Earth would likely be a much colder and drier place. Some scientists also believe that plate tectonics, the movement of large plates on a planet's surface, is important for regulating a planet's climate and recycling nutrients. Earth is the only known planet in our solar system with active plate tectonics. Venus, which is similar in size and mass to Earth, does not have plate tectonics and has a much hotter and denser atmosphere. The search for habitable exoplanets is a challenging but exciting endeavor. We're looking for planets that are not just within the habitable zone, but also have the right combination of factors to support life. This requires a deep understanding of planetary science, geology, atmospheric science, and astrobiology. So, how do we assess the habitability of exoplanets? One way is to study their atmospheres. By analyzing the light that passes through a planet's atmosphere, astronomers can determine its chemical composition and search for signs of biosignatures, molecules that are indicative of life. Some potential biosignatures include oxygen, methane, and ozone. However, the detection of a biosignature is not a guarantee of life. These molecules can also be produced by non-biological processes. For example, oxygen can be produced by the breakdown of water molecules by ultraviolet light. Therefore, it is important to consider the context in which a biosignature is detected and to look for multiple lines of evidence. Another way to assess the habitability of exoplanets is to study their star. The type of star a planet orbits can have a significant impact on its habitability. For example, red dwarf stars are much smaller and cooler than our Sun. Planets orbiting red dwarf stars are typically tidally locked, meaning that one side of the planet always faces the star and the other side always faces away. This can lead to extreme temperature differences between the two sides of the planet. Red dwarf stars also emit strong flares, bursts of radiation that can be harmful to life. However, red dwarf stars are also very long-lived, which means that planets orbiting them could have a long time to evolve life. Despite the challenges, the search for habitable exoplanets is progressing rapidly. New telescopes and instruments are being developed that will allow us to study exoplanet atmospheres in more detail. The James Webb Space Telescope, launched in 2021, is a powerful new tool for exoplanet research. It is equipped with advanced spectrographs that can analyze the light from exoplanet atmospheres and search for biosignatures. The European Extremely Large Telescope, ELT, currently under construction in Chile, will be the world's largest optical telescope. It will be able to directly image exoplanets and study their atmospheres in unprecedented detail. As we continue our search for exoplanets, we are also grappling with profound philosophical questions. Are we alone in the universe? Is life a rare and precious phenomenon, or is it common throughout the cosmos? The discovery of even one habitable exoplanet would have a profound impact on our understanding of our place in the universe. It would suggest that life is not unique to Earth and that it may be widespread throughout the galaxy. This would raise even more questions about the origin and evolution of life. How did life arise on Earth? Were the conditions necessary for life to emerge? Could life exist in forms that are radically different from what we know? The search for exoplanets is not just a scientific endeavor. but also a deeply human one. It is driven by our innate curiosity about the universe and our desire to understand our place within it. As we gaze up at the stars, we're not just looking at distant points of light, but also at the possibility of other worlds, other civilizations, and other forms of life. The exploration of exoplanets is a journey into the unknown, a quest to answer some of the most fundamental questions about our existence. So, as you drift off to sleep tonight, dream of distant worlds, of habitable planets, and of the possibility of life beyond Earth. The universe is vast and full of wonder, and the search for exoplanets is just one small part of our ongoing quest to understand it. The study of exoplanets has revealed an astounding diversity of planetary systems, far beyond what we had imagined based on our own solar system. We've discovered planets orbiting multiple stars, planets with highly eccentric orbits, and planets that are much larger or smaller than anything we see in our own backyard. One of the most intriguing discoveries is the existence of super-Earths, planets that are more massive than Earth, but less massive than Neptune. These planets are thought to be rocky and could potentially be habitable. We've also found mini-Neptunes, planets that are smaller than Neptune but have thick atmospheres. These planets are likely not habitable, but they could provide valuable insights into the formation and evolution of planetary atmospheres. The diversity of exoplanets challenges our understanding of how planetary systems form. The standard model of planet formation, known as the core accretion model, proposes that planets form from the gradual accumulation of dust and gas in a protoplanetary disk around a young star. However, this model struggles to explain the existence of hot Jupiters, which are gas giants that orbit very close to their host stars. These planets are thought to have formed further out in the protoplanetary disk and then migrated inwards. Several mechanisms have been proposed to explain planetary migration, including gravitational interactions with the protoplanetary disk and with other planets in the system. The study of exoplanets is helping us to refine our models of planet formation and to understand the processes that shape the architecture of planetary systems. It is also providing us with a new perspective on our own solar system. We're beginning to realize that our solar system is not necessarily typical and that there are many other ways to arrange a planetary system. As we continue to discover more exoplanets, we are also developing new technologies to study them in more detail. One of the most promising techniques is high-resolution spectroscopy, which allows us to analyze the light from exoplanet atmospheres with unprecedented precision. By studying the absorption and emission lines in the spectrum, we can determine the chemical composition, temperature, and pressure of the atmosphere. This can provide valuable insights into the planet's climate, geology, and potential for habitability. Another promising technique is transit spectroscopy, which involves studying the light that passes through a planet's atmosphere during a transit. As the starlight passes through the atmosphere, certain wavelengths are absorbed by the molecules in the atmosphere. By analyzing the pattern of absorption, we can identify the molecules that are present. Transit spectroscopy has already been used to detect water vapor, methane, and other molecules in the atmospheres of several exoplanets. In the future, we hope to use these techniques to search for biosignatures in the atmospheres of habitable exoplanets. This will require a new generation of telescopes and instruments that are specifically designed for exoplanet research. The James Webb Space Telescope is a major step in this direction, but even more powerful telescopes will be needed to detect biosignatures in the atmospheres of Earth-sized planets orbiting sun-like stars. The search for exoplanets is a long and challenging endeavor, but it is one that is full of promise. With each new discovery, we are getting closer to answering the fundamental question of whether we are alone in the universe. As you drift off to sleep, let your mind wander to the distant stars and the possibility of other worlds, other civilizations, and other forms of life. The universe is vast and full of wonder, and the search for exoplanets is just one small part of our ongoing quest to understand it. Beyond the search for Earth-like planets within the habitable zone, scientists are also exploring the possibility of life existing in more unconventional environments. The concept of a habitable zone is based on the assumption that life requires liquid water. However, some scientists believe that life could potentially exist in other liquids, such as ammonia or methane. This opens up the possibility of life on planets that are much colder or much hotter than Earth. For example, Titan, Saturn's largest moon, has lakes and rivers of liquid methane on its surface. While the temperature on Titan is far too cold for liquid water, some scientists believe that life could potentially exist in the methane lakes. Another possibility is life on planets that are tidally locked to their stars. As we discussed earlier, these planets have one side that always faces a star and one side that always faces away. This can lead to extreme temperature differences between the two sides of the planet. However, some scientists believe that life could potentially exist in the twilight zone between the day and night sides of the planet, where the temperature is more moderate. The search for life beyond Earth is not limited to planets. Some scientists believe that life could potentially exist on moons, asteroids, or even free-floating planets that are not orbiting a star. These rogue planets could potentially harbor liquid water beneath their surfaces, heated by geothermal activity. The possibilities are endless, and we're only just beginning to explore the full range of environments where life could potentially exist. As we continue our search for exoplanets, it is important to keep an open mind and to consider all the possibilities. Life may be more adaptable and resilient than we previously thought. The discovery of even one example of life beyond Earth would revolutionize our understanding of biology and our place in the universe. It would also raise profound ethical questions about how we should interact with other forms of life. The search for exoplanets is not just a scientific endeavor, but also a deeply human one. It is driven by our innate curiosity about the universe and our desire to understand our place within it. As you drift off to sleep, let your mind wander to the distant stars and the possibility of other worlds, other civilizations, and other forms of life. The universe is vast and full of wonder, and the search for exoplanets is just one small part of our ongoing quest to understand it. As our understanding of exoplanets continues to grow, so too does our ability to imagine the possibilities of life beyond Earth. We are no longer limited to the assumption that life requires Earth-like conditions. We are beginning to explore the full range of environments where life could potentially exist, from the methane lakes of Titan to the twilight zones of tidally locked planets. We are also developing new technologies to search for biosignatures in the atmospheres of exoplanets. The James Webb Space Telescope is a major step in this direction, but even more powerful telescopes will be needed to detect biosignatures in the atmospheres of Earth-sized planets orbiting sun-like stars. The search for exoplanets is a long and challenging endeavor, but it is one that is full of promise. With each new discovery, we're getting closer to answering the fundamental question of whether we are alone in the universe. As you drift off to sleep, let your mind wander to the distant stars and the possibility of other worlds, other civilizations, and other forms of life. The universe is vast and full of wonder, and the search for exoplanets is just one small part of our ongoing quest to understand it. Consider the sheer scale of the universe, with its billions of galaxies, each containing billions of stars, and each star potentially hosting multiple planets. The odds of life existing only on Earth seem infinitesimally small. It is far more likely that life is widespread throughout the cosmos, in forms that we can scarcely imagine. Perhaps there are civilizations far more advanced than our own, with technologies that are beyond our comprehension. Perhaps there are simpler forms of life, microbial organisms thriving in the most extreme environments. The possibilities are endless, and we are only just beginning to scratch the surface. The search for exoplanets is not just a scientific endeavor, but also a spiritual one. It is a quest to understand our place in the universe and to connect with something larger than ourselves. As you drift off to sleep, let your mind wander to the distant stars and the possibility of other worlds, other civilizations, and other forms of life. The universe is vast and full of wonder, and the search for exoplanets is just one small part of our ongoing quest to understand it. Imagine standing on the surface of a distant exoplanet, looking up at the alien sky. What would you see? Would there be multiple suns, casting strange shadows across the landscape? Would the sky be a different color, due to the different composition of the atmosphere? Would there be other planets visible in the sky, hanging like moons in the distance? The possibilities are endless, and we can only begin to imagine the wonders that await us on these distant worlds. Perhaps there are planets with towering mountains carved by ancient glaciers. Perhaps there are planets with vast oceans teeming with strange and exotic life. Perhaps there are planets with lush rainforests filled with the sounds of alien creatures. The universe is a vast and diverse place, and there is no limit to what we might find as we continue our exploration of exoplanets. The search for exoplanets is not just a scientific endeavor, but also an artistic one. It is a source of inspiration for writers, artists, and musicians who are using their creativity to imagine the possibilities of life beyond Earth. Science fiction has long been fascinated by the idea of exoplanets, and many of our most beloved stories are set on distant worlds. These stories help us to imagine the future of humanity and to consider the ethical implications of our exploration of the cosmos. As we continue our search for exoplanets, we are not just expanding our scientific knowledge, but also our cultural imagination. We are creating a new mythology, a new set of stories about our place in the universe. As you drift off to sleep, let your mind wander to the distant stars and the possibility of other worlds, other civilizations, and other forms of life. The universe is vast and full of wonder, and the search for exoplanets is just one small part of our ongoing quest to understand it. The discovery of exoplanets has not only expanded our understanding of the universe, but has also sparked a renewed sense of wonder and curiosity about our place within it. It has forced us to reconsider our assumptions about the uniqueness of Earth and the possibility of life existing elsewhere. The search for exoplanets is a testament to human ingenuity and our relentless pursuit of knowledge. It is a journey that will continue for generations to come as we develop new technologies and explore the vastness of the cosmos. As you drift off to sleep, let your mind wander to the distant stars and the possibility of other worlds, other civilizations, and other forms of life. The universe is vast and full of wonder, and the search for exoplanets is just one small part of our ongoing quest to understand it. The implications of discovering life beyond Earth would be profound, challenging our understanding of biology, evolution, and our place in the cosmos. It would raise fundamental questions about the nature of life itself and the conditions necessary for its emergence. It would also have significant social, political, and ethical implications, forcing us to confront our responsibilities to other forms of life and to consider the potential impact of our actions on other worlds. The search for exoplanets is not just a scientific endeavor, but a deeply human one, driven by our innate curiosity, our desire to explore, and our longing to connect with something larger than ourselves. It is a journey that will continue to inspire us, challenge us, and ultimately transform us as we strive to unravel the mysteries of the universe and discover our place within it. So, as you close your eyes and prepare for sleep, let your thoughts drift to those distant worlds, those exoplanets orbiting far-off stars, and allow yourself to dream of the possibilities that await us among the stars. The universe is vast and full of wonder, and the search for exoplanets is just one small part of our ongoing quest to understand it. And as you slumber, consider the sheer scale of the endeavors undertaken to even detect these faint flickers of light from distant stars, the meticulous calculations, the years of dedicated observation, and the collaborative spirit that unites scientists across the globe in this grand quest. It's a reminder that even the most ambitious goals can be achieved through perseverance, ingenuity, and a shared passion for unraveling the mysteries of the cosmos. The very act of searching for exoplanets is a testament to our boundless curiosity and our unwavering belief in the power of human reason. It's a story of exploration, discovery, and the enduring quest to understand our place in the vast tapestry of the universe. Think for a moment about the technological marvels that enable us to glimpse these faraway worlds. Telescopes like the James Webb Space Telescope, a testament to human engineering and scientific ambition, are pushing the boundaries of what we can observe. Its infrared eyes pierce through cosmic dust, revealing details of exoplanetary atmospheres that were once unimaginable. This allows us to not only detect the presence of these planets, but also to analyze their composition, searching for the telltale signs of water, oxygen, or other molecules that could indicate the presence of life. It's like holding a prism up to the starlight, separating it into its constituent colors, and reading the chemical fingerprints etched within. Imagine the dedication of the scientists and engineers who designed, built, and launched these incredible instruments. Years of planning, testing, and refinement went into every component, every circuit, every mirror. It's a testament to the power of collaboration, the ability of countless individuals to pool their expertise and resources to achieve a common goal. The search for exoplanets is not just a scientific endeavor. It's a human endeavor driven by our collective desire to understand the universe and our place within it. And as these telescopes gaze out into the cosmos, they're not just collecting data, they're collecting dreams, the hopes and aspirations of a generation of scientists who believe that we are not alone in the universe. Consider the challenges involved in detecting an exoplanet. We're talking about spotting a tiny speck of dust orbiting a distant star, a star that is often billions of times brighter than the planet itself. It's like trying to see a firefly next to a searchlight from miles away. The techniques used to overcome this challenge are ingenious, relying on subtle changes in the star's light or motion to reveal the presence of the orbiting planet. The transit method, for example, detects the slight dimming of a star's light as a planet passes in front of it. This method has been used to discover thousands of exoplanets, providing us with a wealth of information about their sizes, orbital periods, and atmosphere compositions. The radial velocity method, on the other hand, detects the wobble of a star caused by the gravitational pull of an orbiting planet. This method allows us to determine the planet's mass, providing us with further insights into its composition and potential habitability. Both of these methods are incredibly sensitive, requiring precise measurements and sophisticated data analysis techniques. But the rewards are immense, allowing us to paint a picture of these distant worlds and to assess their potential for harboring life. It's like being a cosmic detective, piecing together clues to solve the mystery of whether we are alone in the universe. Think about the sheer diversity of exoplanets that have been discovered. We've found gas giants larger than Jupiter, scorching hot planets orbiting close to their stars, and icy worlds lurking in the darkness of space. We've even found planets that are made of diamond, a testament to the incredible variety of planetary compositions that can exist in the universe. This diversity challenges our preconceived notions about what a planet can be and expands our understanding of the processes that govern planetary formation. It's a reminder that the universe is full of surprises, and that there is still much that we don't know about the formation and evolution of planets. Imagine a planet with two suns in its sky, a world bathed in the perpetual glow of twin stars, or a planet orbiting a red dwarf star, a smaller, cooler star that emits a different kind of light than our own sun. These are just a few of the exotic possibilities that await us as we continue our search for exoplanets. Each new discovery adds another piece to the puzzle, helping us to understand the conditions that are necessary for life to arise and thrive. It's like exploring a vast and uncharted territory, discovering new landscapes and ecosystems with every step. Consider the concept of the habitable zone, the region around a star where temperatures are just right for liquid water to exist on a planet's surface. This is often considered to be a key factor in determining a planet's potential habitability, as liquid water is essential for all known forms of life. However, the habitable zone is not a fixed and immutable region. It can vary depending on the star's size, temperature, and luminosity, as well as the planet's atmospheric composition and reflectivity. A planet with a thick atmosphere, for example, may be able to maintain liquid water on its surface, even if it is located outside of the traditional habitable zone. Think about the potential for life to exist in unexpected places. Perhaps life could exist beneath the icy surface of a frozen moon, warmed by geothermal vents and protected from the harsh radiation of space. Or perhaps life could exist in the clouds of a gas giant, floating in an atmosphere rich in organic molecules. We don't yet know the limits of life's adaptability, and it's possible that life could exist in environments that we currently consider to be uninhabitable. The search for exoplanets is not just about finding planets that are similar to Earth. It's about exploring the full range of possibilities and expanding our understanding of what life can be. Imagine the moment when we finally discover definitive evidence of life beyond Earth. It would be a moment of profound significance, changing our understanding of our place in the universe and challenging our assumptions about the nature of life itself. It would be a moment that would unite humanity in a shared sense of wonder and excitement. It would also raise a number of important questions about our responsibilities to other forms of life and the ethical implications of our exploration of the cosmos. How will we interact with an alien civilization? Will we attempt to communicate with them? Will we attempt to colonize their planet? These are just some of the questions that we would need to consider if we were to discover life beyond Earth. Consider the potential for future discoveries in the field of exoplanet research. As our technology improves, we will be able to detect smaller and smaller planets and to analyze their atmospheres in greater detail. We may even be able to detect signs of technology, such as artificial light or radio signals emanating from distant worlds. The possibilities are endless, and the future of exoplanet research is bright. The search for exoplanets is not just a scientific endeavor. It's a journey into the unknown, a quest to unravel the mysteries of the universe and to discover our place within it. And as you drift off to sleep, remember that you are a part of this grand adventure, a citizen of the cosmos, connected to the stars and the planets by the very atoms that make up your being. You are a witness to one of the most exciting periods of scientific discovery in human history, a time when we are on the verge of answering one of the most fundamental questions of all. Are we alone in the universe? So close your eyes, relax your mind, and let your dreams take you on a journey to the distant stars, where new worlds await discovery and the possibilities are as vast as the universe itself. Think about the philosophical implications of discovering life beyond Earth. It would challenge our anthropocentric view of the universe, forcing us to reconsider our place in the cosmic order. It would raise questions about the meaning of life, the nature of consciousness, and the existence of God. It would also have a profound impact on our understanding of ourselves, forcing us to confront our own limitations and to appreciate the fragility of life on Earth. Imagine the impact on religion, philosophy, and art. The discovery of extraterrestrial life would undoubtedly spark intense debate and discussion, challenging long-held beliefs and inspiring new forms of creative expression. It would be a moment of profound cultural and intellectual upheaval, forcing us to reevaluate our values and to redefine our understanding of what it means to be human. Consider the potential for collaboration with extraterrestrial civilizations. If we were to discover a civilization that is more advanced than our own, what could we learn from them? Could they teach us how to solve some of the pressing problems facing humanity, such as climate change, poverty, and disease? Could they offer us new insights into the nature of the universe and the meaning of life? The possibilities are both exciting and daunting, and the challenges of communicating and cooperating with an alien civilization would be immense. Think about the potential dangers of encountering an extraterrestrial civilization. Would they be friendly? Would they be hostile? Would they be indifferent to our existence? We simply don't know, and the risks of making contact with an alien civilization are significant. It's important to proceed with caution and to carefully consider the potential consequences of our actions before attempting to communicate with any extraterrestrial life forms. Imagine the future of space exploration. As we continue to develop new technologies, we will be able to travel farther and faster into space, exploring new worlds and searching for signs of life. We may even be able to establish permanent settlements on other planets, becoming a multi-planetary species. The challenges of space exploration are immense, but the rewards are even greater. The future of humanity may depend on our ability to explore and colonize other worlds. Consider the importance of protecting our own planet. As we search for life beyond Earth, we must also remember to protect the precious life that exists on our own planet. We are facing a number of serious environmental challenges, including climate change, deforestation, and pollution. It's important to take action to address these challenges and to ensure that future generations will be able to enjoy the beauty and bounty of our planet. The search for exoplanets is not just about finding new homes for humanity. It's about appreciating and protecting the home that we already have. And as you finally succumb to sleep, let the vastness of the cosmos wash over you, a reminder of the infinite possibilities that lie beyond our world. Let the knowledge that scientists are tirelessly working to unravel the mysteries of the universe bring you comfort and inspiration. Let the dream of discovering life beyond Earth fill you with hope and wonder. The universe is waiting to be explored, and you are a part of that exploration. Sleep well and dream of distant stars and undiscovered worlds. May your dreams be filled with the wonders of the cosmos and the endless possibilities that await us among the stars. Think about the sheer audacity of the human spirit, the unwavering determination to explore the unknown, to push the boundaries of knowledge, and to seek answers to the most fundamental questions about our existence. The search for exoplanets is a testament to this spirit, a reflection of our insatiable curiosity and our unyielding belief in the power of human ingenuity. It's a story of perseverance, collaboration, and the enduring quest to understand our place in the vast and mysterious universe. Imagine the challenges that early astronomers faced with their primitive telescopes and limited understanding of the cosmos. Yet, despite these limitations, they were able to make groundbreaking discoveries, laying the foundation for our modern understanding of the universe. From Galileo's observations of the moons of Jupiter to Hubble's discovery of the expanding universe, each milestone has brought us closer to unraveling the secrets of the cosmos. And now, with the advent of powerful telescopes and sophisticated data analysis techniques, we are on the verge of making even more profound discoveries, including the discovery of life beyond Earth. Consider the contributions of countless scientists, engineers, and technicians who have dedicated their lives to the search for exoplanets. They are the unsung heroes of this grand adventure, working tirelessly behind the scenes to design, build, and operate the instruments that allow us to glimpse these faraway worlds. They are driven by a passion for knowledge, a commitment to excellence, and a belief in the importance of exploring the universe. Their dedication and expertise are essential to the success of this endeavor, and their contributions should be celebrated. Think about the role of education in fostering a passion for science and inspiring the next generation of explorers. By teaching children about the wonders of the universe and the importance of scientific inquiry, we can cultivate a sense of curiosity and wonder that will last a lifetime. We can also empower them to become critical thinkers and problem solvers, equipping them with the skills they need to address the challenges facing humanity in the 21st century. Education is the key to unlocking the potential of future generations and ensuring that the quest for knowledge continues for centuries to come. Imagine the impact of exoplanet discoveries on the arts and humanities. The discovery of life beyond Earth would undoubtedly inspire new forms of creative expression, challenging our assumptions about the nature of art and the role of the artist in society. It would also raise profound ethical and philosophical questions, forcing us to reconsider our values and to redefine our understanding of what it means to be human. The arts and humanities play a crucial role in shaping our understanding of the world and in helping us to make sense of our place within it. Consider the importance of international collaboration in the search for exoplanets. This is a global endeavor requiring the expertise and resources of scientists and engineers from around the world. By working together, we can pool our knowledge and resources to achieve goals that would be impossible to achieve alone. International collaboration is essential to the success of this endeavor. It also promotes peace and understanding between nations. Think about the potential for commercial applications of exoplanet research. The technologies developed for the search for exoplanets could also be used for a variety of other purposes, such as improving our understanding of climate change, developing new energy sources, and creating new medical devices. The economic benefits of exoplanet research could be significant, and they could help to improve the lives of people around the world. Imagine the future of humanity among the stars. As we continue to explore the universe, we may eventually establish permanent settlements on other planets, becoming a multi-planetary species. This would be a monumental achievement, ensuring the survival of humanity in the face of potential threats to our existence on Earth. The future of humanity may depend on our ability to explore and colonize other worlds. Consider the importance of preserving the night sky. As our cities grow and our use of artificial light increases, the night sky is becoming increasingly obscured. This has a negative impact on our ability to observe the stars and planets, and it also diminishes our sense of wonder and connection to the cosmos. It's important to take steps to reduce light pollution and to preserve the beauty of the night sky for future generations. And as sleep gently claims you, remember that the search for exoplanets is more than just a scientific endeavor. It's a reflection of our deepest hopes and dreams, our yearning to understand the universe and our place within it. It's a journey that will continue for generations to come, and you are a part of that journey. So close your eyes, relax your mind, and let your dreams take you on a voyage of discovery to the distant stars, where new worlds await and the possibilities are endless. Sleep soundly, knowing that the quest for knowledge continues, and that the universe is full of wonder and mystery waiting to be unveiled. Let your dreams be filled with images of far-off galaxies, swirling nebulae, and the promise of new life waiting to be discovered. The cosmos is vast, and our exploration has only just begun. Think about the immense scale of the universe, the billions of galaxies, each containing billions of stars, and the countless planets that orbit those stars. It's a humbling thought, reminding us of our own insignificance in the grand scheme of things. Yet, it's also an inspiring thought, suggesting that there is an infinite amount to discover and explore. The universe is a vast and mysterious place, and we are only just beginning to scratch the surface of its secrets. Imagine the potential for discovering new laws of physics as we explore exoplanets. By studying the extreme environments of these distant worlds, we may be able to test our current theories and to uncover new phenomena that challenge our understanding of the universe. The search for exoplanets could lead to breakthroughs in our understanding of gravity, electromagnetism, and the fundamental forces of nature. Consider the role of citizen science in the search for exoplanets. Anyone can participate in this grand adventure by analyzing data collected by telescopes and searching for signs of planets. Citizen science projects provide valuable contributions to the field of exoplanet research, and they also help to engage the public in the process of scientific discovery. Think about the potential for developing new technologies inspired by exoplanet research. The challenges of detecting and studying exoplanets are driving innovation in a variety of fields, including optics, electronics, and data analysis. These new technologies could have a wide range of applications, from improving our medical imaging techniques to developing new forms of renewable energy. Imagine the impact of exoplanet discoveries on our understanding of evolution. By studying the conditions on other planets, we can gain insights into the factors that influence the evolution of life. We may even be able to discover new forms of life that are radically different from anything we have ever seen before. The search for exoplanets could revolutionize our understanding of the origins and evolution of life in the universe. Consider the ethical implications of contacting an extraterrestrial civilization. Should we attempt to communicate with them? What message should we send? What are the potential risks and benefits of making contact? These are complex questions that require careful consideration, and there is no easy answer. The decision to contact an extraterrestrial civilization should be made with the utmost caution and with a full awareness of the potential consequences. Think about the importance of protecting exoplanets from contamination. If we were to discover life on another planet, it would be crucial to protect that planet from contamination by Earth-based organisms. We must develop strict protocols for space travel and planetary exploration to ensure that we do not inadvertently introduce life to other worlds. Imagine the future of space tourism. As space travel becomes more affordable, it may become possible for ordinary people to travel to space and to experience the wonders of the universe firsthand. Space tourism could provide a new source of revenue for space exploration, and it could also inspire a new generation of scientists and engineers. Consider the role of space law in regulating human activities in space. As we continue to explore and colonize space, it will be necessary to develop a comprehensive legal framework to govern our activities. This framework should address issues such as resource allocation, environmental protection, and the settlement of disputes. And as you finally drift into a deep and restful sleep, let the wonders of exoplanet discoveries fill your dreams. Imagine yourself traveling to distant worlds, exploring alien landscapes, and encountering new forms of life. Let the vastness of the universe inspire you and fill you with a sense of awe and wonder. Sleep well and dream of the infinite possibilities that await us among the stars. May your dreams be filled with the beauty and mystery of the cosmos, and may you wake up refreshed and ready to continue the quest for knowledge and understanding. The universe is calling, and we must answer. Think about the challenges of interstellar travel. Even with the most advanced technology, it would take many years to travel to the nearest star system. The distances between stars are vast, and the energy requirements for interstellar travel are enormous. However, scientists are working on developing new propulsion systems that could make interstellar travel a reality in the future. Imagine the potential for creating self-sustaining colonies on other planets. By utilizing the resources available on those planets, we could create closed-loop ecosystems that could support human life indefinitely. This would require developing new technologies for resource extraction, food production, and waste recycling. However, the rewards of creating self-sustaining colonies on other planets would be immense. Consider the role of robotics in space exploration. Robots can be sent to explore environments that are too dangerous or too difficult for humans to access. They can also perform tasks that are too repetitive or too tedious for humans to do. Robots are essential tools for space exploration, and they will play an increasingly important role in the future. Think about the potential for using asteroids as sources of raw materials. Asteroids contain vast quantities of valuable resources, such as water, minerals, and metals. These resources could be used to build space habitats, to fuel spacecraft, and to manufacture products in space. Asteroid mining could become a major industry in the future, providing a new source of wealth and opportunity for humanity. Imagine the impact of discovering a planet that is even more habitable than Earth. Such a planet could become a refuge for humanity in the event of a catastrophe on Earth. It could also provide a new home for those who are seeking a better life. The discovery of a super habitable planet would be a momentous event in human history. Consider the ethical implications of terraforming other planets. Terraforming is the process of modifying a planet's atmosphere, temperature, and surface conditions to make it more habitable for humans. However, terraforming could also have unintended consequences, such as disrupting the planet's existing ecosystem or altering its climate in unpredictable ways. The decision to terraform another planet should be made with careful consideration of the potential risks and benefits. Think about the importance of protecting the Earth's environment. As we explore and colonize space, we must not forget to protect our own planet. We must take steps to reduce pollution, to conserve resources, and to mitigate climate change. The Earth is our only home, and we must take care of it. Imagine the future of education in space. As we establish permanent settlements on other planets, we will need to provide education for the children who are born there. Space schools could offer unique learning opportunities, such as studying the planets and stars firsthand. They could also foster a sense of community and connection among the settlers. Consider the role of art and music in space colonization. Art and music can provide comfort, inspiration, and a sense of connection to home for those who are living on other planets. They can also help to build community and to celebrate the human spirit. Art and music will be essential components of any successful space colony. And as you finally succumb to the embrace of sleep, let the wonders of the universe fill your mind and soothe your soul. Dream of traveling to distant stars, exploring alien worlds, and encountering new forms of life. Let the vastness of the cosmos inspire you to reach for the stars and to never give up on your dreams. Sleep peacefully, knowing that the quest for knowledge continues and that the universe is full of endless possibilities. May your dreams be filled with the beauty and mystery of the cosmos, and may you wake up refreshed and ready to face the challenges and opportunities of the day. The universe is waiting to be explored, and we are all a part of that exploration. Think about the importance of international cooperation in addressing the challenges facing humanity. Climate change, poverty, disease, and terrorism are all global problems that require global solutions. By working together, we can pool our resources and expertise to overcome these challenges and to create a better future for all. Imagine the potential for using space-based solar power to provide clean energy for the Earth. Solar power satellites could collect sunlight in space and beam it back to Earth, providing a constant source of clean energy. This could help to reduce our reliance on fossil fuels and to mitigate climate change. Consider the role of artificial intelligence in space exploration. AI could be used to control robots, to analyze data, and to make decisions in space. AI could also help us to communicate with extraterrestrial civilizations. AI will be an essential tool for space exploration in the future. Think about the potential for creating space elevators to transport people and materials to space. Space elevators would be much cheaper and more efficient than rockets, making it easier to access space. Space elevators could revolutionize space travel and make it possible to build large-scale space habitats. Imagine the impact of discovering evidence of past life on Mars. This would be a monumental discovery, providing evidence that life can arise elsewhere in the universe. It would also raise profound questions about the origins and evolution of life. Consider the ethical implications of sending messages into space to attract the attention of extraterrestrial civilizations. Some scientists believe that this could be dangerous, as it could attract the attention of hostile civilizations. Others believe that it is worth the risk, as it could lead to contact with a friendly civilization. The decision to send messages into space should be made with careful consideration of the potential risks and benefits. Think about the importance of protecting the Earth from asteroid impacts. Asteroid impacts have caused mass extinctions in the past, and they could pose a threat to humanity in the future. We must develop technologies to detect and deflect asteroids that are on a collision course with Earth. Imagine the future of human evolution in space. As humans adapt to life on other planets, they may evolve into new species. This could lead to a diversification of human life throughout the galaxy. Consider the role of philosophy in shaping our understanding of the universe. Philosophy can help us to grapple with the big questions about life, the universe, and everything. It can also help us to develop ethical frameworks for guiding our actions in space. And as you drift off to sleep, let the wonders of space and the search for exoplanets fill your mind with peace and tranquility. Know that even as you rest, scientists around the world are diligently working to unravel the mysteries of the cosmos, pushing the boundaries of human knowledge and striving to answer the age-old question, are we alone? Let the vastness of space remind you of the infinite possibilities that lie before us. And let the dream of discovering new worlds and new forms of life inspire you to live a life filled with purpose, curiosity, and wonder. Sleep well, and may your dreams be filled with the beauty and majesty of the universe. Think about the importance of inspiring future generations to pursue careers in science, technology, engineering, and mathematics STEM. STEM fields are essential for addressing the challenges facing humanity in the 21st century, from climate change to disease to poverty. We must encourage young people to pursue careers in STEM by providing them with access to quality education, role models, and opportunities for hands-on learning. Imagine the potential for creating artificial habitats in space. These habitats could be used to house scientists, engineers, and tourists. They could also be used to grow food and to manufacture products in space. Artificial habitats could provide a comfortable and sustainable environment for humans to live and work in space. Consider the role of nanotechnology in space exploration. Nanotechnology could be used to create new materials that are stronger, lighter, and more durable than existing materials. It could also be used to create tiny robots that can explore planets and asteroids. Nanotechnology could revolutionize space exploration and make it possible to achieve goals that are currently impossible. Think about the potential for using fusion power to propel spacecraft. Fusion power is a clean and abundant source of energy that could be used to power spacecraft for long-duration missions. Fusion-powered spacecraft could travel to distant stars and planets much faster than current spacecraft. Imagine the impact of discovering definitive evidence of intelligent life beyond Earth. This would be a watershed moment in human history, changing our understanding of our place in the universe and raising profound questions about the nature of consciousness, the meaning of life, and the future of humanity. Consider the ethical implications of interfering with the evolution of life on other planets. Should we attempt to guide the evolution of life on other planets to make it more compatible with human life? Or should we allow life to evolve naturally, even if it means that it may never be able to coexist with humans? These are complex ethical questions that require careful consideration. Think about the importance of protecting the Earth from space debris. Space debris is a growing problem that could pose a threat to satellites and spacecraft. We must develop technologies to remove space debris from orbit and to prevent the creation of new debris. Imagine the future of space warfare. Space is becoming an increasingly important domain for military operations. We must develop international agreements to prevent space warfare and to ensure that space is used for peaceful purposes. Consider the role of religion in shaping our response to the discovery of extraterrestrial life. Different religions may have different interpretations of the meaning of extraterrestrial life. It is important to have a respectful and open dialogue between science and religion about the implications of the discovery of extraterrestrial life. And as you peacefully transition into slumber, remember the sheer wonder and awe that the universe inspires. Think of the countless stars twinkling in the night sky, each one a sun, perhaps surrounded by its own family of planets. Let the knowledge that our understanding of the cosmos is constantly expanding fill you with a sense of hope and possibility. Dream of new discoveries, of uncovering the secrets of distant worlds, and of perhaps one day finding evidence that we are not alone in this vast and magnificent universe. Sleep well, knowing that the quest for knowledge continues, and that the universe is waiting to reveal its wonders to those who dare to explore. May your dreams be filled with the beauty and mystery of the cosmos, and may you wake up refreshed and ready to embrace the day ahead. The universe is calling, and we must answer. And as we drift further into the realm of slumber, let your thoughts wander to the possibility of terraforming distant planets. Imagine transforming a barren, inhospitable world into a lush, habitable environment, a second Earth teeming with life. This is not mere science fiction. It's a concept grounded in scientific principles, albeit one that presents immense technological and ethical challenges. Terraforming would require drastically altering a planet's atmosphere, temperature, and surface conditions to make it suitable for human habitation. One proposed method involves releasing vast quantities of greenhouse gases into the atmosphere to trap heat and warm the planet. Another involves using genetically engineered organisms to modify the soil and create a more hospitable environment. While the prospect of terraforming is exciting, it also raises profound ethical questions about our responsibility to other potential life forms and the potential consequences of altering an entire planet's ecosystem. Consider the potential of space-based solar power. The sun is an inexhaustible source of energy, and harnessing its power in space could provide a clean and sustainable energy source for Earth. Space-based solar power stations would collect sunlight and convert it into electricity, which could then be transmitted back to Earth via microwaves or lasers. This technology could revolutionize energy production and reduce our reliance on fossil fuels. However, it also presents significant engineering challenges, including the cost of building and maintaining the solar power stations in space and the potential environmental impacts of transmitting energy back to Earth. Think of the possibilities. Powering entire cities with clean energy collected from the sun, eliminating pollution from power plants, and reducing our carbon footprint. Imagine the day when we discover a planet with a breathable atmosphere, liquid water, and signs of plant life. This would be a monumental discovery, confirming that life is not unique to Earth and opening up the possibility of colonizing another planet. Such a discovery would have profound implications for our understanding of the universe and our place in it. It would also raise new questions about the origin of life, the evolution of intelligence, and the future of humanity. Consider the impact on our society, our culture, and our beliefs. It would be a turning point in human history, ushering in a new era of exploration and discovery. Think about the challenges of interstellar travel. Reaching even the closest stars would require traveling at speeds approaching the speed of light, a feat that is currently beyond our technological capabilities. Interstellar travel would also require overcoming the challenges of long-duration spaceflight, including the effects of radiation exposure, weightlessness, and psychological isolation. One potential solution is to develop new propulsion systems, such as fusion rockets or warp drives, that could enable us to travel at faster speeds. Another is to develop advanced life support systems that could sustain astronauts for decades or even centuries. Imagine the journey, traveling for generations aboard a spacecraft, exploring new worlds and encountering new civilizations. Consider the possibility of encountering extraterrestrial civilizations. What would happen if we made contact with another intelligent species? Would they be friendly or hostile? Would they be more advanced than us or less advanced? The potential consequences of such a meeting are difficult to predict, but it is important to consider the ethical and practical implications. We must develop protocols for communicating with extraterrestrial civilizations and for responding to their actions. We must also consider the potential risks of revealing our existence to other civilizations, including the risk of invasion or exploitation. Imagine the cultural exchange, the sharing of knowledge, and the potential for collaboration. It would be a transformative experience for both civilizations, reshaping our understanding of the universe and our place in it. And as you continue to relax and prepare for sleep, let your mind explore the concept of the multiverse. The multiverse is a hypothetical collection of multiple universes, possibly including our own, which together comprise everything that exists. The entirety of space, time, matter, energy, and the physical laws and constants that describe them. In other words, it's the idea that our universe might just be one of countless others, each with its own unique set of physical laws and constants. Some universes might be almost identical to ours, while others might be radically different. Some might be governed by entirely different laws of physics, leading to unimaginable possibilities. The concept of the multiverse arises from various theories in physics, including quantum mechanics, string theory, and inflationary cosmology. While there is currently no direct experimental evidence to support the existence of the multiverse, it remains a fascinating and potentially profound idea that could revolutionize our understanding of the cosmos. Imagine the implications: countless versions of ourselves existing in different universes, each living out different lives. It's a mind-boggling concept that pushes the boundaries of our imagination. Think about the potential for using artificial intelligence to explore space. AI could be used to analyze vast amounts of data collected by telescopes and spacecraft, to identify potential targets for exploration, and to control robots and probes on distant planets. AI could also be used to design new spacecraft and propulsion systems, and to develop new strategies for exploring the universe. Imagine AI-powered spacecraft autonomously exploring the cosmos, discovering new planets, and searching for signs of life. AI could be our tireless and fearless explorer, venturing into the unknown and expanding our knowledge of the universe. Consider the ethical implications of creating artificial life. Should we create artificial life? What rights would artificial life forms have? What responsibilities would we have to them? These are complex ethical questions that require careful consideration. The creation of artificial life could have profound implications for our understanding of life, consciousness, and the nature of being. It could also raise new questions about our relationship to technology and our responsibility to the future. Imagine a world where artificial life forms coexist with humans, working alongside us, exploring the universe with us, and contributing to our society. And as sleep begins to gently embrace you, ponder the mystery of dark matter and dark energy. Dark matter is a mysterious substance that makes up about 85% of the matter in the universe. We cannot see it or interact with it directly, but we know it exists because of its gravitational effects on visible matter. Dark energy is an even more mysterious force that is causing the expansion of the universe to accelerate. We know very little about dark matter and dark energy, but understanding them is crucial to understanding the fate of the universe. Imagine the universe filled with these invisible substances, shaping the cosmos and driving its evolution. It's a humbling reminder of how much we still don't know about the universe. Think about the potential for using virtual reality to explore space. VR could allow us to experience what it would be like to walk on the surface of Mars, to fly through the rings of Saturn, or to visit a distant star system. VR could also be used to train astronauts for space missions and to develop new technologies for space exploration. Imagine putting on a VR headset and being transported to another world, exploring alien landscapes, and experiencing the wonders of the universe firsthand. It would be a transformative experience that could inspire a new generation of explorers and scientists. Consider the role of art and music in inspiring space exploration. Art and music can capture the beauty and wonder of the universe and inspire us to explore the unknown. Artists and musicians can create works that celebrate the achievements of space exploration and that imagine the possibilities of the future. Imagine listening to a symphony inspired by the cosmos, or viewing a painting that captures the vastness and beauty of space. Art and music can connect us to the universe in a profound and emotional way, fueling our curiosity and inspiring us to reach for the stars. And as you drift deeper into slumber, contemplate the search for Planet 9. Planet 9 is a hypothetical planet that is thought to exist in the outer solar system. Its existence is inferred from the unusual orbits of several Kuiper Belt objects. If Planet 9 exists, it would be a massive planet, possibly several times the size of Earth, and it would have a highly eccentric orbit that takes it far beyond Pluto. The search for Planet 9 is an ongoing effort, and astronomers are using powerful telescopes to scan the outer solar system for any signs of its presence. Imagine a hidden planet lurking in the darkness, waiting to be discovered. It's a tantalizing mystery that could rewrite our understanding of the solar system. Think about the potential for using 3D printing to build structures in space. 3D printing could be used to build habitats, laboratories, and other structures on the Moon, Mars, or other planets. This technology could reduce the cost and complexity of space missions and make it possible to establish permanent settlements on other worlds. Imagine 3D printers churning out bricks and beams on the moon, constructing a new home for humanity. It would be a revolutionary technology that could transform the future of space exploration. Consider the importance of international cooperation in space exploration. Space exploration is a global endeavor that requires the collaboration of scientists, engineers, and policymakers from around the world. International cooperation can reduce the cost of space missions, share knowledge and resources, and promote peaceful relations between nations. Imagine a world where nations work together to explore the universe, sharing the benefits of discovery and advancing our understanding of the cosmos. It would be a powerful symbol of human unity and a testament to our shared desire to explore the unknown. And as you peacefully succumb to the embrace of sleep, let your thoughts linger on the possibility of wormholes. Wormholes are hypothetical tunnels through space-time that could connect two distant points in the universe. If wormholes exist, they could allow us to travel vast distances in a relatively short amount of time, potentially enabling interstellar travel. However, the existence of wormholes is purely theoretical, and even if they do exist, it is not clear whether they would be traversable or stable. Imagine stepping through a wormhole and emerging on the other side of the galaxy, instantly transported to a distant world. It's a mind-bending concept that could revolutionize our understanding of space and time. Think about the potential for using genetic engineering to adapt humans to life in space. Genetic engineering could be used to enhance our resistance to radiation, to improve our bone density and weightlessness, and to adapt our bodies to the unique challenges of living in space. This technology could make it easier for humans to live and work in space for extended periods of time. Imagine genetically engineered astronauts exploring the cosmos, adapted to thrive in the harsh conditions of space. It would be a controversial technology, but it could also be essential for the future of human space exploration. Consider the role of education in inspiring the next generation of space explorers. Education is crucial to inspiring young people to pursue careers in science, technology, engineering, and mathematics, STEM, and to fostering a passion for space exploration. By providing students with access to high-quality STEM education, we can ensure that the next generation is equipped to meet the challenges and opportunities of the future. Imagine a classroom filled with students eagerly learning about the cosmos, dreaming of becoming astronauts, scientists, and engineers. Education is the key to unlocking the potential of the next generation and to ensuring that we continue to explore the universe for generations to come. And as you finally drift off to sleep, remember the words of Carl Sagan: somewhere, something incredible is waiting to be known. Let that thought fill you with a sense of wonder and excitement, and let it inspire you to continue to explore the universe, whether through science, art, or simply through your imagination. Sleep well and dream of the stars. The universe is vast and mysterious, and it is waiting to be explored. As your mind begins to quiet and your body relaxes, allow yourself to ponder the sheer scale of the universe. We've talked about exoplanets, potentially habitable worlds, and even the possibility of encountering other intelligent life. But let's take a step back and consider the bigger picture. Our solar system, with its single star and handful of planets, is just one tiny speck in the vast Milky Way galaxy. The Milky Way is a spiral galaxy containing hundreds of billions of stars, along with vast clouds of gas and dust. And even our massive galaxy is just one of billions of galaxies in the observable universe. Each galaxy is like its own island universe, containing countless stars, planets, and possibly life. When you consider the sheer number of galaxies, the number of stars and planets becomes almost incomprehensible. It's a truly humbling thought, one that puts our own existence into perspective. Think about the distances involved in space travel. Even traveling to the closest star system, Alpha Centauri, would take thousands of years with our current technology. The vast distances between stars and galaxies pose a significant challenge to space exploration. We need to develop new propulsion systems that can travel at much faster speeds, or find ways to overcome the limitations of space and time. Perhaps one day we will discover a way to travel through wormholes or to warp space around our spacecraft, allowing us to traverse vast distances in a relatively short amount of time. Imagine the possibilities: exploring distant galaxies, visiting alien civilizations, and uncovering the secrets of a universe. Consider the possibility that life may exist in forms that we cannot even imagine. We tend to think of life as being based on carbon and water, but there may be other forms of life that are based on different elements or that exist in entirely different environments. Perhaps there are life forms that exist in the atmospheres of gas giant planets, or that live deep beneath the surfaces of icy moons. We need to be open to the possibility that life may be much more diverse and adaptable than we currently believe. Imagine discovering life forms that are based on silicon, or that can survive in extreme temperatures and pressures. It would revolutionize our understanding of biology and our place in the universe. And as you continue to drift towards sleep, let your mind wander to the future of humanity in space. Will we one day become a multi-planetary species, colonizing Mars, the Moon, and other worlds? Will we build massive space stations and orbiting cities, creating new habitats for humans in the vacuum of space? Will we venture beyond our solar system, exploring distant stars and galaxies? The possibilities are endless, and the future of humanity in space is limited only by our imagination and our technological capabilities. Imagine a future where humans live and work in space, contributing to our understanding of the universe and expanding our horizons. It's a future that is both exciting and challenging, and one that requires our commitment and our dedication. Think about the potential for using space resources to benefit humanity. The moon, asteroids, and other celestial bodies are rich in valuable resources, such as water, minerals, and rare earth elements. These resources could be used to build habitats, manufacture goods, and fuel spacecraft. Mining space resources could provide a new source of wealth and prosperity for humanity, and could help us to solve some of the challenges facing our planet. Imagine a future where we are mining asteroids for valuable minerals and using lunar water to create rocket fuel. It would be a sustainable and environmentally friendly way to access the resources we need to thrive. Consider the role of citizen science in space exploration. Citizen science projects allow ordinary people to participate in scientific research by analyzing data, identifying patterns, and making discoveries. Citizen scientists can contribute to a wide range of space exploration projects, from searching for exoplanets to mapping the surface of Mars. By involving the public in scientific research, we can increase our understanding of the universe and inspire a new generation of scientists and explorers. Imagine millions of people around the world analyzing data from telescopes, searching for signs of life on other planets. It would be a powerful demonstration of the collective intelligence of humanity and a testament to our shared desire to explore the cosmos. And as you finally succumb to the gentle embrace of sleep, remember that the universe is a vast and wondrous place, full of mysteries waiting to be uncovered. Sleep well and dream of the stars. May your dreams be filled with the beauty and mystery of the cosmos, and may you wake up refreshed and ready to embrace the day ahead. The universe is calling, and we must answer. The search for life beyond Earth is not just a scientific endeavor. It's a deeply human one. It speaks to our inherent curiosity, our longing to understand our place in the cosmos, and our desire to connect with others, even if those others are extraterrestrial. It's a quest that has captivated humanity for centuries, from ancient philosophers speculating about other worlds to modern scientists using sophisticated telescopes to scan the skies for signs of life. The very act of searching for life elsewhere forces us to confront fundamental questions about what it means to be alive, what conditions are necessary for life to arise, and whether we are truly alone in the vast expanse of the universe. This profound exploration goes beyond the realm of science, touching upon philosophy, religion, and our deepest existential yearnings. Imagine the sheer impact of discovering a thriving ecosystem on another planet, reshaping our understanding of the universe and our place within it. The implications of finding extraterrestrial life would be monumental, affecting every aspect of human society. Our understanding of biology would be revolutionized, as we would be forced to expand our definition of life to encompass forms that may be radically different from anything we have ever encountered on Earth. Our philosophical and religious beliefs would be challenged as we grapple with the question of whether we are unique or simply one of many civilizations scattered throughout the cosmos. Our technology would advance at an unprecedented rate as we strive to communicate with and learn from our newfound cosmic neighbors. The discovery of extraterrestrial life would be a watershed moment in human history, ushering in a new era of scientific exploration, philosophical inquiry, and technological innovation. It would force us to reevaluate our place in the universe and our relationship with all living things. Consider the potential for international collaboration in space exploration. Space exploration is an inherently global endeavor, requiring the cooperation and collaboration of scientists, engineers, and policymakers from around the world. By working together, we can pool our resources, share our expertise, and accelerate the pace of discovery. International collaborations, such as the International Space Station and the James Webb Space Telescope, have already demonstrated the power of collective effort in pushing the boundaries of human knowledge. Imagine a future where nations unite to build massive interstellar spacecraft, capable of traversing the vast distances between stars. It would be a testament to the power of human cooperation and our shared desire to explore the universe. Such collaborations not only advance scientific knowledge, but also foster peace and understanding among nations, uniting us in a common goal that transcends national boundaries. Think about the ethical considerations of space exploration and the search for extraterrestrial life. As we venture further into the cosmos, it is essential that we consider the ethical implications of our actions. We must ensure that we do not contaminate other planets with Earth-based organisms, and that we respect any life forms that we may encounter. We must also consider the potential impact of our actions on the environment of other planets and strive to minimize our footprint. The search for extraterrestrial life raises profound ethical questions about our responsibilities to the cosmos and to any potential inhabitants of other worlds. Imagine a scenario where we discover a primitive civilization on another planet. How should we interact with them? Should we attempt to communicate with them? Should we leave them alone to develop on their own? These are complex ethical questions that require careful consideration. And as you continue to relax and prepare for sleep, ponder the future of space travel and the technologies that will enable us to reach the stars. For centuries, humanity has dreamed of traveling to other worlds, and now that dream is within reach. Advances in rocketry, propulsion systems, and life support technologies are making interstellar travel a real possibility. Imagine a future where we have developed warp drive or other advanced propulsion systems, allowing us to travel to distant stars in a matter of years or even months. Imagine building massive space stations that serve as stepping stones to the stars, allowing us to refuel and resupply our spacecraft along the way. The future of space travel is filled with possibilities, and it is only a matter of time before we begin to explore the vast expanse of the galaxy. This journey will require not only technological breakthroughs, but also a spirit of adventure and a willingness to take risks, pushing the boundaries of human exploration to new heights. Consider the possibility of terraforming other planets, transforming them into habitable worlds for humans. Terraforming is the process of modifying a planet's atmosphere, temperature, surface topography, and ecology to be similar to Earth's environment, making it habitable for humans and other terrestrial life forms. Mars, for example, is a potential candidate for terraforming, although the process would be long and challenging. Imagine a future where we have successfully terraformed Mars, creating a new home for humanity beyond Earth. It would be a monumental achievement, demonstrating our ability to adapt and thrive in even the most hostile environments. Terraforming raises profound ethical questions about our responsibility to other planets and whether we have the right to alter their environments to suit our needs. However, it also offers the potential to expand our reach into the cosmos and ensure the long-term survival of our species. Think about the potential for discovering new resources in space that could benefit humanity. The moon, asteroids, and other celestial bodies are rich in valuable resources, such as water, minerals, and rare earth elements. These resources could be used to build habitats, manufacture goods, and fuel spacecraft. Mining space resources could provide a new source of wealth and prosperity for humanity, and could help us to solve some of the challenges facing our planet. Imagine a future where we are mining asteroids for precious metals and using lunar water to create rocket fuel. It would be a sustainable and environmentally friendly way to access the resources we need to thrive, reducing our reliance on Earth's finite resources. Space-based resources could also drive innovation in manufacturing and technology, creating new industries and jobs. Consider the role of artificial intelligence in space exploration. Artificial intelligence is playing an increasingly important role in space exploration, from analyzing data from telescopes to controlling spacecraft. AI algorithms can be used to identify patterns in vast data sets, allowing us to discover new exoplanets and other celestial objects. AI-powered robots can be sent to explore remote planets and moons, collecting data and performing experiments without the need for human intervention. Imagine a future where AI systems are autonomously exploring the galaxy, searching for signs of life and sending back valuable data to Earth. AI could also assist in the design and construction of space habitats, optimizing resource usage and ensuring the safety and well-being of human occupants. The integration of AI into space exploration will accelerate the pace of discovery and allow us to explore the cosmos more efficiently and effectively. And as you feel yourself drifting off to sleep, reflect on the sheer scale and wonder of the universe. Our solar system is just one tiny speck in a vast galaxy, which in turn is just one of billions of galaxies in the observable universe. The distances between stars and galaxies are so immense that they're almost impossible to comprehend. And yet, despite its vastness, the universe is governed by a set of physical laws that are both elegant and predictable. By studying the cosmos, we can gain a deeper understanding of the fundamental nature of reality and our place within it. Imagine traveling to the edge of the observable universe, gazing back at our own galaxy as a tiny point of light. It would be a humbling and awe-inspiring experience, reminding us of the insignificance of our planet in the grand scheme of things. Think about the mysteries of dark matter and dark energy, which make up the vast majority of the universe's mass and energy. Dark matter is an invisible substance that does not interact with light, but whose presence can be inferred from its gravitational effects on galaxies and other celestial objects. Dark energy is a mysterious force that is causing the expansion of the universe to accelerate. Scientists are still trying to understand the nature of dark matter and dark energy, and their discovery would revolutionize our understanding of cosmology and fundamental physics. Imagine discovering the particles that make up dark matter or understanding the source of dark energy. It would be a monumental achievement, unlocking some of the deepest secrets of the universe. Consider the possibility of parallel universes and the multiverse. Some theories in physics suggest that our universe may be just one of many universes existing in a vast multiverse. These other universes may have different physical laws, different constants of nature, and even different dimensions. The concept of the multiverse is highly speculative, but it raises profound questions about the nature of reality and our place within it. Imagine traveling to another universe, encountering different forms of matter and energy, and experiencing different physical laws. It would be a mind-bending experience, challenging our understanding of everything we thought we knew about the universe. And as sleep gently washes over you, contemplate the search for a unified theory of physics, a single framework that can explain all the fundamental forces and particles in the universe. Scientists have been searching for a unified theory for decades, and its discovery would be a major breakthrough in our understanding of the cosmos. String theory and loop quantum gravity are two promising candidates for a unified theory, but neither has yet been experimentally verified. Imagine discovering the ultimate equation that describes the universe, a single elegant formula that explains everything from the smallest subatomic particles to the largest galaxies. It would be the culmination of centuries of scientific inquiry and a testament to the power of human reason. Think about the ongoing efforts to detect gravitational waves, ripples in the fabric of space-time caused by accelerating massive objects. The detection of gravitational waves has opened up a new window on the universe, allowing us to study black holes, neutron stars, and other extreme objects in a way that was never before possible. The Laser Interferometer Gravitational Wave Observatory, LIGO, has already detected gravitational waves from several merging black holes, and future gravitational wave detectors will be even more sensitive, allowing us to probe deeper into the cosmos. Imagine detecting gravitational waves from the Big Bang, giving us a glimpse into the earliest moments of the universe. It would be a profound achievement, providing invaluable insights into the origins of the cosmos. Consider the potential for using quantum computing to solve some of the most challenging problems in astrophysics. Quantum computers are a new type of computer that uses the principles of quantum mechanics to perform calculations that are impossible for classical computers. Quantum computers could be used to simulate the behavior of black holes, model the formation of galaxies, and analyze vast data sets from telescopes. The development of quantum computers has the potential to revolutionize astrophysics and other fields of science. Imagine using a quantum computer to simulate the conditions inside a black hole, allowing us to understand the nature of gravity at its most extreme. It would be a major step forward in our quest to understand the universe. And as you finally surrender to the embrace of slumber, remember that the universe is a vast and mysterious place, full of wonders waiting to be discovered. Sleep soundly and dream of the stars. May your dreams be filled with the beauty and mystery of the cosmos. and may you wake up refreshed and ready to explore the world around you. The universe awaits, and our journey of discovery has only just begun. Think about the potential for using advanced telescopes, both on Earth and in space, to study the atmospheres of exoplanets. By analyzing the light that passes through the atmospheres of exoplanets, we can determine their composition and search for signs of life, such as the presence of oxygen or methane. The James Webb Space Telescope is already providing unprecedented views of exoplanet atmospheres, and future telescopes will be even more powerful, allowing us to probe deeper into the cosmos. Imagine discovering an exoplanet with an atmosphere that is strikingly similar to Earth's, suggesting the possibility of a habitable world. It would be a monumental discovery, inspiring us to continue our search for life beyond Earth. Consider the ethical implications of sending messages to extraterrestrial civilizations. The search for extraterrestrial intelligence, SETI, has been searching for radio signals from other civilizations for decades, and some scientists have proposed sending messages to potential extraterrestrial neighbors. However, there is also concern that sending messages to extraterrestrial civilizations could be dangerous, as we do not know their intentions. The ethical implications of sending messages to extraterrestrial civilizations are complex and require careful consideration. Imagine receiving a message from an extraterrestrial civilization. How will we respond? Will we be able to understand their message? Will they be friendly or hostile? These are questions that we need to consider before we send any messages into the cosmos. And as you drift deeper into sleep, ponder the possibility of encountering other intelligent civilizations in the universe. The universe is so vast that it seems almost impossible that we're the only intelligent civilization. If there are other intelligent civilizations, what would they be like? Would they be more advanced than us? Would they be friendly or hostile? The possibility of encountering other intelligent civilizations is both exciting and terrifying. Imagine encountering an extraterrestrial civilization that is far more advanced than us. What will we learn from them? Would they help us to solve our problems? Or would they exploit us for their own gain? These are questions that have captivated humanity for centuries, and they remain unanswered. Think about the challenges of interstellar communication. The vast distances between stars make interstellar communication extremely challenging. Even if we could send a message to another star system at the speed of light, it would take years, decades, or even centuries for the message to arrive. And it would take just as long for a reply to reach us. The challenges of interstellar communication are daunting, but they are not insurmountable. Imagine developing a technology that could transmit information instantaneously across vast distances. It would revolutionize interstellar communication and allow us to communicate with other civilizations in real time. Consider the potential for building self-replicating machines that could explore the galaxy. Self-replicating machines, also known as von Neumann probes, are hypothetical machines that can create copies of themselves. If we could build self-replicating machines, we could send them to explore the galaxy, searching for resources and sending back information to Earth. Self-replicating machines could explore the galaxy much faster and more efficiently than human-crewed spacecraft. Imagine sending a fleet of self-replicating machines to explore the galaxy, mapping its stars and planets, and searching for signs of life. It would be a monumental undertaking, but it could revolutionize our understanding of the cosmos. And as you gently slip into slumber, remember that the search for life beyond Earth is one of the most profound and important endeavors that humanity has ever undertaken. It is a quest that speaks to our deepest curiosity, our longing to understand our place in the universe, and our desire to connect with others, even if those others are extraterrestrial. Sleep peacefully and dream of the stars. May your dreams be filled with the beauty and wonder of the cosmos, and may you wake up refreshed and ready to continue the journey of discovery. The universe is calling, and we must answer. The sheer audacity of searching for life on other planets, trillions of miles away, highlights the indomitable spirit of human curiosity. It's a testament to our relentless pursuit of knowledge, our unwavering desire to unravel the mysteries of the universe. This quest is not just about finding life. It's about understanding the very fabric of existence, the origins of life, and the potential for life to flourish in diverse and unexpected environments. Each discovery, each new exoplanet identified, each tantalizing hint of a biosignature fuels our imagination and pushes us closer to answering the age-old question, are we alone? This ambition is not frivolous. It's a fundamental drive that has propelled human progress throughout history, from the first explorers charting unknown lands to the scientists pushing the boundaries of scientific understanding today. Imagine, for a moment, the technological marvels that enable us to peer into the depths of space, to analyze the faint light from distant stars, and to infer the presence of planets orbiting them. Telescopes like the James Webb Space Telescope are not just instruments. They're time machines, allowing us to glimpse the universe as it was billions of years ago. The sophisticated algorithms and data analysis techniques used to process the information gathered by these telescopes are a testament to human ingenuity and our ability to create tools that extend our senses beyond their natural limitations. These advancements are not just for scientific purposes. They have ripple effects, driving innovation in other fields, from medicine to material science, and ultimately improving the quality of life for all. The search for exoplanets also forces us to confront our own biases and assumptions about what life can be. We tend to think of life as we know it on Earth, based on carbon chemistry and requiring liquid water. But the universe may hold surprises, life forms that are based on different chemical elements or that can thrive in environments that we consider uninhabitable. The discovery of extremophiles, organisms that can survive in extreme temperatures, pressures, and radiation levels, has broadened our understanding of the possibilities of life. We must be open to the idea that life may exist in forms that we cannot even imagine, challenging our preconceived notions and expanding our definition of what it means to be alive. The exploration of space is not without its challenges and risks. The vast distances, The harsh environments and the potential for unforeseen dangers require careful planning, advanced technology, and a spirit of resilience. But the potential rewards are immense, not only in terms of scientific knowledge, but also in terms of human inspiration and the expansion of our horizons. The challenges of space exploration push us to innovate, to develop new technologies, and to work together to overcome seemingly insurmountable obstacles. This process fosters a sense of collaboration, shared purpose, and a belief in the power of human ingenuity to solve even the most complex problems. And as you begin to feel the weight of sleep pulling you down, consider the philosophical implications of finding life beyond Earth. Such a discovery would fundamentally alter our understanding of our place in the universe and our relationship to all living things. It would challenge our anthropocentric worldview, forcing us to recognize that we are not the center of the cosmos, and that life may be more common than we previously thought. It would also raise profound ethical questions about our responsibility to other life forms and the potential for conflict or cooperation between different civilizations. The discovery of extraterrestrial life would be a transformative event, reshaping our understanding of ourselves and our place in the grand scheme of things. Think about the potential for using space as a source of inspiration and education. Space exploration captures the imagination of people of all ages, inspiring them to pursue careers in science, technology, engineering, and mathematics (STEM). Seeing images of distant galaxies, alien planets, and the vastness of the cosmos can spark a sense of wonder and curiosity, motivating individuals to learn more about the universe and their place within it. Space exploration also provides a powerful platform for education, allowing us to teach students about physics, astronomy, and other scientific disciplines in an engaging and inspiring way. By investing in space exploration, we are investing in the future of education and the development of a scientifically literate society. Consider the importance of protecting our own planet as we explore the possibility of finding life elsewhere. While the search for exoplanets is exciting and inspiring, it is essential that we do not lose sight of the importance of protecting our own planet, Earth. Earth is a unique and precious oasis in the vastness of space, and we have a responsibility to preserve its biodiversity, protect its environment, and ensure its long-term sustainability. By learning more about exoplanets, we can gain a better understanding of the conditions that make Earth habitable and the factors that could threaten its habitability. The search for life beyond Earth should inspire us to appreciate and protect the life that we already have on our own planet. And as you finally succumb to the soothing embrace of sleep, remember that the universe is a vast and wondrous place, full of mysteries waiting to be uncovered. Sleep well and dream of the stars. May your dreams be filled with the beauty and mystery of the cosmos, and may you wake up refreshed and ready to embrace the day ahead. The universe is calling, and we must answer. Imagine a future where humans are not confined to Earth, but have established thriving colonies on other planets and in space. This vision, once relegated to science fiction, is becoming increasingly plausible as technology advances and our understanding of the universe deepens. Establishing self-sustaining colonies on other planets would require solving numerous challenges, including developing closed-loop life support systems, finding sustainable sources of energy and resources, and protecting colonists from the harsh environment of space. But the potential rewards are immense, including ensuring the long-term survival of humanity, expanding our knowledge of the universe, and opening up new frontiers for exploration and innovation. Think about the potential for using space-based solar power to provide clean and sustainable energy for Earth. Space-based solar power involves collecting solar energy in space and transmitting it to Earth, where it can be used to generate electricity. Space-based solar power has several advantages over terrestrial solar power, including the fact that it can operate 24 hours a day, 7 days a week, and it is not affected by weather conditions. Space-based solar power could provide a clean and sustainable source of energy for Earth, reducing our reliance on fossil fuels and mitigating the effects of climate change. Imagine a future where massive solar power satellites orbit the Earth, providing clean energy to billions of people. It would be a transformative technology, helping us to create a more sustainable and prosperous future. Consider the role of private companies in space exploration and development. Private companies are playing an increasingly important role in space exploration and development, investing in new technologies, launching satellites, and even planning human missions to the Moon and Mars. Private companies can bring innovation, efficiency, and a willingness to take risks that are often lacking in government-funded programs. The involvement of private companies in space exploration is accelerating the pace of discovery and opening up new opportunities for commercial development. Imagine a future where private companies are competing to build lunar bases, mine asteroids, and transport tourists to space. It would be a dynamic and exciting era of space exploration, driven by both scientific curiosity and economic opportunity. And as you drift further into the realm of slumber, ponder the long-term future of humanity in the cosmos. Will we eventually spread throughout the galaxy, colonizing countless planets and encountering other intelligent civilizations? Will we evolve into a multi-planetary species, adapting to the diverse environments of other worlds? Or will we remain confined to Earth, facing the challenges of climate change, resource depletion, and other existential threats? The long-term future of humanity in the cosmos is uncertain, but it is ultimately up to us to shape our destiny. By embracing science, innovation, and cooperation, we can ensure that humanity has a bright and prosperous future among the stars. Think about the importance of international cooperation in space exploration. Space exploration is an inherently global endeavor, requiring the collaboration and cooperation of scientists, engineers, and policymakers from around the world. By working together, we can pool our resources, share our expertise, and accelerate the pace of discovery. International collaborations, such as the International Space Station and the James Webb Space Telescope, have already demonstrated the power of collective effort in pushing the boundaries of human knowledge. Imagine a future where nations unite to build massive interstellar spacecraft, capable of traversing the vast distances between stars. It would be a testament to the power of human cooperation and our shared desire to explore the universe. Consider the ethical implications of space colonization. As we begin to colonize other planets, it is essential that we consider the ethical implications of our actions. We must ensure that we do not repeat the mistakes of the past, such as exploiting indigenous populations or damaging fragile ecosystems. We must also consider the rights of future generations and ensure that they have the opportunity to thrive in the new worlds that we create. Space colonization presents both opportunities and challenges, and it is essential that we approach it with wisdom, foresight, and a deep respect for all living things. Imagine a future where humans live in harmony with the environment on other planets, creating sustainable and equitable societies. It would be a testament to our ability to learn from the past and build a better future for all. And as you finally succumb to the gentle embrace of sleep, remember that the universe is a vast and wondrous place, full of mysteries waiting to be uncovered. Sleep well and dream of the stars. May your dreams be filled with the beauty and mystery of the cosmos, and may you wake up refreshed and ready to embrace the day ahead. The universe is calling, and we must answer. The exploration of exoplanets and the search for life beyond Earth is not just a scientific endeavor. It's a testament to the enduring human spirit of curiosity and exploration. It represents our innate desire to understand our place in the universe and to connect with something larger than ourselves. As we continue to push the boundaries of knowledge and technology, we may one day find evidence of life on another planet, forever changing our understanding of the cosmos and our place within it. Until then, let us continue to dream of the stars and to strive for a future where humanity can explore and appreciate the wonders of the universe. The search for exoplanets and the potential for extraterrestrial life isn't solely about scientific discovery. It ignites our imagination and inspires us to question our place in the grand cosmic tapestry. Think about the sheer scale of the universe, with its billions of galaxies, each containing billions of stars, and each star potentially hosting a retinue of planets. The possibility that we are alone in this vast expanse seems statistically improbable. The discovery of even microbial life on another planet would revolutionize our understanding of biology, forcing us to redefine what it means to be alive and how life can arise in different environments. It would open up entirely new avenues of research and exploration, challenging our current scientific paradigms and pushing the boundaries of human knowledge. Consider the implications for our own planet. By studying exoplanets, we can gain a better understanding of the factors that make a planet habitable and the conditions that are necessary for life to arise and thrive. We can learn about the processes that shape planetary atmospheres, climates, and geological activity, and we can use this knowledge to better understand the challenges facing our own planet, such as climate change and resource depletion. The study of exoplanets can provide us with valuable insights into the fragility and resilience of life and the importance of protecting our own planet's unique environment. Think of Earth as a precious, irreplaceable gem in the vast cosmos, a haven for life that we must cherish and protect for future generations. The technological advancements driving exoplanet discovery are nothing short of astounding. From the radial velocity method, which detects the wobble of a star caused by the gravitational pull of an orbiting planet, to the transit method, which observes the slight dimming of a star as a planet passes in front of it, scientists are employing increasingly sophisticated techniques to detect these distant worlds. The James Webb Space Telescope, with its unprecedented sensitivity and resolution, is revolutionizing our ability to study exoplanet atmospheres, searching for telltale signs of water, oxygen, and other molecules that could indicate the presence of life. These technological marvels are not just tools for scientific discovery. They're testaments to human ingenuity and our unwavering determination to explore the unknown. Imagine a future where we have mapped the atmospheres of dozens, perhaps hundreds, of potentially habitable exoplanets, analyzing their chemical compositions and searching for signs of biosignatures, indicators of life, such as methane or oxygen. We might even be able to detect the presence of technologically advanced civilizations by searching for artificial signals or structures. This is not science fiction. It is a realistic possibility within our lifetimes. The search for life beyond Earth is one of the most ambitious and exciting scientific endeavors of our time, and it has the potential to transform our understanding of the universe and our place within it. As you drift further into sleep, consider the profound philosophical implications of discovering life beyond Earth. It would challenge our anthropocentric worldview, forcing us to confront the possibility that we are not unique or special in the universe. It would raise profound questions about the nature of consciousness, the origins of life, and the meaning of existence. The discovery of extraterrestrial life would have a profound impact on our culture, our religions, and our understanding of ourselves. It would be a turning point in human history, ushering in a new era of exploration, discovery, and self-reflection. Think about the potential challenges and opportunities that would arise from contact with an alien civilization. Would they be friendly or hostile? Would they share their knowledge and technology with us? Or would they seek to exploit us for their own purposes? The prospect of contact with an alien civilization is both exciting and daunting, and it is essential that we prepare ourselves for the possibility of such an encounter. We must develop protocols for communication, diplomacy, and defense, and we must ensure that any contact is conducted in a responsible and ethical manner. The future of humanity may depend on our ability to navigate the complexities of interstellar relations. And as you finally succumb to the gentle embrace of slumber, remember that the search for exoplanets is not just a scientific quest. It is a reflection of our deepest human desires, the desire to explore, to discover, and to understand our place in the universe. It is a testament to our unwavering curiosity and our relentless pursuit of knowledge. Sleep well and dream of the distant worlds that await us among the stars. May your dreams be filled with the wonders of the cosmos, and may you wake up refreshed and inspired to continue the search for life beyond Earth. The universe is vast, mysterious, and full of possibilities. Let us embrace the challenge of exploring it, and let us never lose sight of our shared humanity. The future of humanity lies among the stars, waiting to be discovered. And as we continue to explore and learn, we are also discovering more about ourselves, our potential, and our place in the grand cosmic story. The exploration of exoplanets, therefore, is an inward journey as much as an outward one. It is a journey of self-discovery, of understanding our origins, and of shaping our destiny. So, close your eyes, relax, and let the wonders of the cosmos fill your mind. Sleep soundly, knowing that the universe is unfolding exactly as it should, and that you are an integral part of its magnificent story.